Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, from today onwards, we are going to practice transformers through topic-wise MCQ series. This series will be very useful for all your competitive examination. Let us start the session. And students, a small introduction about myself. I have 6 years of teaching experience in online platform, worked at Unacademy Plus, and I have cleared many of written examinations, and so many of my students got selected in various JEE and AE examinations. Let us take the first question, guys. Which of the following does not change in a transformer? We know very well transformer is a static device in which the constant terms are, what are the constant quantities? Constant quantities. Power is always constant, and also frequency. Power and frequency are constant terms. What are the variable? Variable terms. We know transformer can step up the voltage and also step down the voltage. That means variable are voltage. And whenever the power is constant means product of voltage into current is constant. Okay. So if you increase the voltage, what is happening to current? It will be decreased to maintain the constant power. In the same way, if you decrease the voltage, current has to be increased to maintain the constant power. So that means current also variable quantity. And one more quantity is there, that is flux, magnetic flux. This magnitude of flux also always constant. Okay, we require time varying flux. Or that is nothing but alternating flux. But the magnitude of flux is always constant. Okay, so here constant terms are power, frequency or magnitude of flux. Here frequency given, so the answer is option C. Coming to the next one, in a transformer the energy is conveyed from primary to secondary through dash. We know very well, if it is a transformer core, in transformer have two windings. This is the one winding, this is the second winding. Okay, so the winding which is connected to the supply, is nothing but you can say primary. Okay, the winding which is connected to the load is nothing but you can say secondary. It is always secondary. Okay, it is always primary. So what is the primary winding? The winding which is connected to the supply, that is primary, which is connected to the load, that is the secondary. Okay, so here whenever you give the supply to the primary, then current is flowing. So whenever the current flowing through the coil, then flux will be produced. Here this is the magnetic core now. This provide low reluctance path. That is less opposition to the magnetic flux. So the magnetic flux will be flowing through the magnetic core and it will be connected to the secondary winding. Okay, so that means here energy is conveyed from primary to secondary through the flux, by the flux. So answer is option C. Coming to the next question, transformer action requires dash. Just now I have given, in the transformer action, EMF E is equal to minus N d pi by dt. Minus is due to Lenz's law. Okay, so here d pi by dt, that is flux has to be vary with respect to time. That is time varying flux. We require time varying flux. I mean alternating flux. Okay, alternating flux. For example, if you are giving constant flux, that means time invariant flux, then what will happen? D pi by dt will become 0. Whenever the d pi by dt becomes 0, EMF is 0. This will happen in case if you provide the DC supply. Whenever the EMF is 0, that is no opposition. Whenever there is no opposition, then primary winding going to be burn. So if you give DC supply to a transformer, then primary winding is going to be burn. Okay, here transformer action requires D, that is change in flux, that is alternating flux. Answer is option D. In a transformer, primary flux is always dash the secondary flux. Already I have given what are the constant terms. What are the constant terms in magnitude? Magnitude of power is constant. Okay, magnitude of frequency is constant, and also magnitude of flux is also constant. So primary flux is always equal to secondary flux. Okay, secondary flux, that is equal. Maybe some flux may be less in practical. Why? Because of some leakage flux. Okay, but in ideal case we are always take same flux in the primary and secondary. Why? Because power is constant now. So a transformer dash, I already given a transformer step up or step down the voltages. Whenever the voltage changes, current automatically changes. Vi is equal to constant. So if you increase the voltage, automatically current is decreases. Why? Because it has to be maintained constant. Okay, here step up the voltage. If whenever the step up the voltage, current is stepping down. Okay, the same way, if you decrease the voltage, current has to be increased. This will be happen in case of AC only. DC primary winding is going to be but no transformer action. So step up or step down, AC voltages and also currents. Okay, for DC it may not work. A step up transformer converts dash into dash. Step up or step down, or step up or step down, these are belongs to voltage terms. Okay, belongs to voltage terms. So step up means voltage is increases. Okay, as voltage increases, what happened to the current is less. In the same way, step down means voltage is stepped down. As voltage stepped down means current is increases. Okay, here by maintaining power as constant. Okay, so step up transformer converts. Here voltage increases means less voltage to high voltage. So low voltage to high voltage. So low voltage to high voltage. So low voltage at high current to low voltage at high current to high voltage at low current. So the answer is option C. Okay. So in step up transformer, what it will do? It will increase the voltage. So that means it converts low voltage to high voltage. Okay, whenever the voltage is low, at the time current is high. So automatically current high to low. So low voltage high current to low voltage high current to high voltage low current. Okay, so option is C. Coming to the next question. Primary winding of a transformer. I already said transformer having two windings. Until unless if you are giving the supply, we can't say this winding is belongs to primary, this winding is belongs to secondary. Okay, so whenever you give the supply to the winding, then it will becomes primary. I already said now, whenever you connect one winding to the load, then it will becomes secondary. So then primary may be high voltage winding or low voltage winding. Okay, so windings are only low voltage and high voltage. Okay, for example, if it has more turns, it will becomes high voltage winding. If it is a less turns, it is a low voltage winding. Okay, so we have only two windings. Those are HV and LV. The winding which is connected to the primary, which is connected to the supply is primary, which is connected to the load is secondary. Okay, so primary may be either LV or HV. In the transformer, following winding has got more cross-sectional area. So area we are going to construct depending upon the current. Whenever the more current, more area. Okay. So in which winding having high current requires high cross section area. So in which winding? Low voltage. Whenever the voltage is low, current is high. Okay. So for low voltage winding has more cross section area. Okay. Low voltage winding having more cross section area. Coming to the next one. Which winding in the transformer has more number of turns? So this number of turns N2 by N1 is equal to V2 by V1, that is equal to I1 by I2. Okay, that is nothing but transformation ratio K. Transformation ratio, you can also call it as K. Okay, so which winding having more number of turns? The winding which is having high voltage is having more number of turns. So number of turns are proportional to voltage, or voltage proportional to number of turns. Okay. So here higher the voltage, high number of turns required. So high voltage winding having more number of turns. Okay. Isolation transformer has primary to secondary turns ratio. The isolation transformer is nothing but the turns ratio is nothing but 1:1. Okay, turns ratio is 1:1. That means the voltage ratio also 1:1. So it may not step up or step down the voltages. Then why it is required? So in electronic circuits, if you want to isolate, then and if you want to shock proof, then we use this isolation type of the transformer. So if you want from one winding or one circuit to other circuit as isolation required, then we use this isolation transformer. Okay, here transformation will be done through the flux. Flux is not shock. Okay, so that means this is required in electronic circuits. The ratio is 1:1. What will be the transformation ratio? Just now I have given transformation ratio is K, that is N2 by N1, that is V2 by V1. Okay, so here voltage is they have given 110 by 550, that is equal to 1 by 5, that is 0.2. Okay, 1 by 5, that is 0.2. The answer is option D. A single phase 50H transformer has voltage ratio 2200 by 220. The transformation ratio same, K is equal to V2 by V1, 110, that is equal to 1 by 10. So the answer is option C. Students, here we are discussing topic wise MCQs. Okay, so we are taking the basic topic, and in the basic topic the expected questions. And students, if you have not subscribed this channel, please click on subscribe button, and also please share the information to all your friends. The transformer used for AC welding set. In AC welding set, we require low voltage, high current is the requirement. Correct? It is our requirement. So if you want to get low voltage, then we have to use step down transformer. So the answer is option C. In a transformer, the resistance between its primary and secondary. We know the basic point belongs to this transformer. The resistance between its primary and secondary is infinite. Why it is infinite? We know in transformer is electrically isolated, magnetically coupled. Okay, so electrically isolated means no direct connection between, no direct contact between two windings. Okay, For example, here if it is the transformer core, here we have the insulation. Upon the insulation only we have the windings. Okay. Upon the insulation only we have the windings. Okay, this one is represented as in this manner also. Is the one winding, it is the other winding. So there is no direct connection. Here we are giving magnetic core. So through the core only the flux is transformed. Okay, so that means energy is conveyed from primary to secondary. So electrically isolated. Electrically isolated means if there is no connection means what about the resistance? Is infinite. Infinite resistance. Okay. Coming to the next one. The main purpose of using magnetic core in a transformer. Just now I have given in magnetic core. So through this one flux will be transformed. Okay. So whenever it has low reluctance, then only total flux will be moved from one winding to another winding. Okay. So otherwise, if it is having high reluctance, that is higher the opposition, so much of flux will be leaks. But we want to transform the flux from transfer this flux from primary to secondary now. So for that we require a magnetic core which provide low reluctance path. Okay, low reluctance path. So core is required to decrease the reluctance of the common magnetic circuit. Coming to the next one, which of the following statement is not true for ideal transformer? Not true for ideal transformer. So if it is ideal transformer, the resistance must be as low as possible, almost zero. But here resistances they have given high, so which is not correct. So not correct is the answer now. So the answer is option A, that are option 1. Okay. So we know some of the characteristics of ideal transformer. Okay. So the resistances are almost zero. Okay. So its permeability has to be infinite, very high permeability. Okay. And leakage flux has to be zero. Whenever the high permeability of the core, it allows all the flux through it, so then there is no leakage. And it must having the losses are zero as much as possible. Okay, as much as possible. And magnetization curve is linear. Whenever the magnetization curve is linear, then no hysteresis losses. Curve is linear. Okay, so these are the main important characteristics of ideal transformer. Okay, and coming to the next one, which of the following properties is not necessarily desirable for the material for transformer core? Not necessarily desirable. Okay, so coming to the low hysteresis loss low is desirable only. High permeability is desirable only. Thermal conductivity, we don't want conductivity. If you have the conductivity, then eddy current losses will be increases. We don't want that one. High mechanical strength, yes, it requires. Otherwise, it is easily damaged, is easily going to be bent. Okay, so it is not at all required. Not at all required is our answer. So high thermal conductivity is not at all required. The desirable properties of transformer core. So the desirable properties of the transformer core. Just now we have discussed the permeability has to be infinite. Low losses. So high permeability and high losses, no, low losses. So the answer is option C. Answer is option C. Coming to the next one. The material which is slightly repelled by a magnetic field is known as dash. So we have three types of magnetic materials: dia, para, ferro. So these para and ferromagnetics are attracted. Why? Because they magnetized in the same direction, but it is magnetized in the opposite direction of the magnetic field. So it may be slightly repelled from the magnetic field. So answer is diamagnetic. Okay. Answer is diamagnetic. And coming to the next one, silicon content in iron lamination is kept within 5%. Why we have to do this lamination? To reduce the area of the core. If you reduce the area of the core, resistance will be increases. Rho L by A. If you decrease the area, resistance increases. As resistance increases, eddy currents will be decreases. So eddy current losses will be decreases. For this purpose, we are going to add, we are going to do the laminations. Okay. So in this lamination, generally to reduce the conductivity and also to reduce the hysteresis losses, we are going to add some silicon content. The silicon content limited to 5%. Why? Because if you add more silicon, the material will becomes brittle. What is meant by brittle? So if you try to bend that one, it may not bend. It will be breaks. It will be breaks. We don't want that property. So that's why we don't want to increase the percentage. If you increase the percentage, then material will becomes brittle. Okay. Stepped core is used in transformer in order to reduce. So whenever we use the stepped core, what is our advantage? Then the advantage is nothing but it can reduce the volume of the copper. We know copper is high cost. Okay, so if you want to reduce the copper, then we have to use the stepped type of the core. That means here it is a one-step type of the core. Here it is a 2-step, 3-step and 4-step. For example, here if you are using 3-step of the core, in this if you want to wind, this much of winding only required. But here upon this we have to use one more. That means in outer turn a lot of copper wire is required. So here less copper wire is required. So that's why we can use the step type of the core to reduce the volume of the copper. Okay. Okay, students, in the next session, we will discuss the remaining important MCQs in the transformer. Okay, so I will give my Telegram link in the description box. You can join in the Telegram group also. Okay, and if you want to download the PDF, you can visit the suneelengineeringacademy.com to download all the electrical engineering PDF. Okay. Students, if you have not subscribed this channel, please subscribe this channel and also share information to all your friends. Thank you, students.